So it is 2:31. The room's looking mighty empty, and I don't see Tony anywhere. Hi, Gunter.
Hey, yeah. So right now you're the single chat in the room here. So.
All right. Yeah, I just sent him text. See where his phone is on silenced. like he's taking a nap. I don't know where he is. He's. I believe he's in town.
So what do you say if Sandy would volunteer to sit in front as a secretary out there?
Let me turn this up. That volume's pretty low. I got this all. There we go. I hear me now. Say something again.
You're loud and clear in the room, so.
Yeah, I've got you turned up max. I can barely hear you. Let me see if there's another knob here I can use. Here's another knob. Okay, everybody's at max. Hey, Sandy's taking over. Awesome.
Yes, I have sent a message to Tony P, but he didn't answer. Yeah, I'm not.
Yeah, I did the same.
Yes.
We've all been kicking him.
Will you control your slides?
I didn't know if you were going to be, and I couldn't find Tony, so I went ahead and shared this up. You want to take it over?
Yeah, if it's better if you can control it because I have a presentation too. Yeah.
Okay, I'll control this then.
Yeah.
If the slides stop moving, just yell at me. I probably fell asleep. I don't think that man has any tour at all.
I still got one XL t-shirt left for free.
Thanks for doing that, by the way. That was great. Do we shut the door and release the hounds? What's the plan? So Sandy, if you could run the show and I'll just run the slides from here, you get a better sense of the room. I'm looking through a tube.
So will you present the working group documents here or just controlled by me?
Oop, there we go.
So Greg, will you start?
Was that to me? Sandy,
Yeah.
was you asking me to run this?
Yes. Do you want to present the working group documents?
Oh, sure. It's 2:30 a.m. I'm almost awake. Probably more asleep than that. This is the note well. Everyone has read this. I could take a vote to the room to make sure this, see if you have done it and put some responsibility in your lap, but we'll just take nods. Everyone nod in the room. You read it? Well noted. Thank you. Next slide. More notes. Gunter.
Hey, Greg, can you move a little bit further away from the mic? You're very loud.
I'm loud?
Yep,
Okay,
yep.
and I can barely hear you. Is this better?
You're so loud.
Better? Worse?
Greg, you're breaking up. There were just small interruptions, so maybe upstream bandwidth issue.
Yeah, that mic is really bad. I can't hear it.
Oh, so you didn't hear us? That was just Gunter, and now it's Torles. Do you hear?
I can see you. I can see here that was said Torles.
Okay, how about we try another mic? Is this any better?
That's way better, yes. And is my mic better? I moved it away from my head.
Swap those.
Yeah, your volume was a lot better now, so thank you.
All right, great. All right, second page of Notewell. Everyone nodded? How to use the tool. Everyone should be logged in as an in-room participant. No more blue sheets. Your attendance is monitored this way. Recording's automatic. You are being recorded. Your actions will be held against you later today. That's a promise.
Your voice is still crackling up like you're 96.
I don't know how to fix that. That just could be a distance problem. I don't know. App. Resources while you're here. And our agenda is pretty quick. We may be done in an hour. That puts me to bed. Anyone who bashed the agenda? Anything else to add or delete?
So can I just make one small note? Yeah, I was just saying, so was it 10 year? So I've got one XL t-shirt left over, and from PIM I've got mugs left over for the standard 100 from PIM. I know this is a third-party working group advertisement, but I missed Ember in the morning. So if you want a mug, come to me after the meeting.
Torres has gifts. Take him up on it. No comments, Linda? All right, we'll move on. Status. Look at this. We have a newly published RFC, BGP extensions for BIER. 97, 93. We're getting close to 5 digits. We might make it. In the queue, we got PHP and FRR. FRR has gotten a lot of pushback so far, some really good comments. I've got some comments to add as well. We'll see what the process takes us through. But I personally would like to see it come back to the group and take a different approach. But I think the group as a whole has to make that call, or at least the ISG may make that call for us. We'll see how it progresses. I think the date got moved out to September now. Isn't that correct? I think I just saw that date update.
Yeah, Gunter speaking, the AD here.
Okay.
So yeah, indeed. So I pushed it out to September to give the authors more time to respond to the observations which were made. And let's see where that actually brings us. About like a week and a half before that date, I will check in again and see where we are.
All right. Sounds great. Thanks, Hunter. Thanks, Dad. Other groups in past working group last call. We have OAM. It's finally ready. It's come and gone numerous times, but it's been refreshed. And we've got some ready for DR review. Any comments on these? Anyone in the room responsible? I think we're keeping the ball kicked down the road pretty consistently now. All right. I guess the only one in question is going to be use cases. It's one of those things we kind of been growing over time, but we've gotten some pushback to turn it into something real and at least, I guess, put a stick in the sand and move it along. And then in case anyone's wondering, this picture, this is a beer beverage. It's different than the beer protocol, just to be clear. All right. First up, payload labels.
And it's a clicker. Torres, you can control it.
Mic
You
check,
got the
mic
power,
check.
Torres.
Mic
I'm
check,
going to
mic
mute.
check. Mic check, mic check, mic check. Can you hear us? This is the third microphone. Now I need an acknowledgement from you. No. You're muted. Okay. Oh, you mean we'll stick with one microphone? Okay. So this is pretty much started as Jeffrey's work, and somehow I got sucked into it because of my history with this MPLS stuff. So last IETF, I think Homan was it that presented of the BIER interop testing, and that uncovered an issue, not actually, I would say, in BIER, but in all these crazy different MPLS type of, there is payload types that we have, and the type of MPLS label we're using for them. And to solve this inconsistency and make it clearer what is actually needed to be put into the BIER protocol field describing what the payload is, we wrote this draft here. So the protocol field in the BIER header has a value of 1, indicating that the payload is an MPLS label stack packet, and the top label is a downstream assigned MPLS label. And the value 2, guess what? It's the same thing, except that the first label to look up is upstream assigned. And that downstream label was, assigned, introduced in RFC 3031. So ancient history. For multicast, it was pretty much meant you're transmitting multicast packets through unicast MPLS, and it is the receiver that takes from his label space a label and tells the upstream LSR, please send me that multicast on that label. So it is under the downstream router can control what the label is, so can takes it from the default label table. And then the upstream label that was introduced in RFC 5332, so not that ancient history anymore. That was when Rosen and the rest of the multicast folks worked out the kinks of MLDP and getting multicast to really work well. the actual RFC that does the assignment is RFC 5331, 53, so that's the one that you folks typically are referring to. The logic was in 5332, which I was co-author on. That's how I got involved in all of this. The idea was, how do we transmit multicast packets as layer 2 multicast? If we transmit them as layer 2 multicast, then obviously the downstream router can't say, well, just send it on the following label, and the next receiver on the same subnet says, well, send it on another wait a second, I'm multicasting, I can send it only once. Somebody has to decide consistently on what the bloody label is. So let's say it's the upstream that decides that, right? The sender decides the label, and of course you need some signaling then to let all the receivers in the subnet decide which label that is for which multicast traffic. Now, that actually, to the best of my knowledge, never got implemented in MLDP or other protocols. An 80s, a working group chair scene. So
I'm here, listening. Keep on.
Yep. So, but RFC 5331 did generalize the point, which is that to capture in a broader MPLS context for different type of use cases that are similar to that 5332, that multicast, layer 2 multicast, they called it context labels, right? So you need some context. In this case, for 5332, it would have been a particular subnet that you receive the packet on. You look up the label in a subnet specific table. And I'm actually not sure if 5331 did actually give any other really good examples for that. But what happened later on was that for things that actually are relevant for multicast over BIER over MPLS, the two type of labels, sRGB labels and DCB labels, with the two RFCs that they have there, 8402 and 9573. And unfortunately, those RFCs didn't really, understand that the text would have had to explicitly say what type of label should be used, right? And that basically left open for guessing what label would be used. And as we see in the interop testing, people have guessed differently. Now, when we were looking at it, how could we remove the ambiguity and what should we do? Well, obviously, multicast downstream labels that you decide on yourself come from the global table. So that is the global LFIP, and the multicast upstream label would come from a context label. And the overall thinking for this draft is that it doesn't really make sense to encode in the code point something which is a particular semantic like upstream, downstream, sRGB, DCB. There are so many different types of semantics of the labels. Those semantics actually can only be known after looking up the label, right? In the forwarding plane, the only thing that we need to know when we are at the stage of looking at the protocol field in BIER is whether to look up the label from the global table or from some context table, right? So we need to really change the semantic of saying the semantic of one is the label that you look up at next is from the global table. Once you're looking up that label, you will know which semantic it is, sRGB, DCB, or a downstream standard good old multicast label. And if the value is 2, well, you know that you need to go into the much more complex forwarding plane where you have to, figure out, oh, what context do I need for this packet? And I'm going to look into the appropriate context LFIP for that, right? So we're bringing down the semantic from something which is very application specific MPLS to something which is really forwarding plane specific, global versus context LFIP. Those are the two code points. And luckily, of course, when it comes to, the pre-existing upstream and downstream users, they're completely backward compatible, right? So just to make sRGB and DCB work, we're not needing to change anything on the wire of the prior stuff like MLDP or others, because upstream and downstream are not going to change in their stuff. We just need to make sure that the text in the RFCs are correctly changed so that people are not confused about the change that we're planning to do in the registry, which is where we're coming to here. So what the registry currently says, one, MPLS downstream, two, MPLS upstream. And what we would like to put in there is one being default LFIP and two being context LFIP, right? So that's the registry change. And anybody who has something which is not sRGB and DCB, but just, you know, existing MLDP or other protocols, well, when you're running them over BIER anyhow, so I'm not even sure if that combination is being deployed, but those wouldn't need any change. It's just the semantic is different, but not the encoding. So here then are the updates proposed, RFC 8296, which is the BIER encapsulation, which created the registry. And that's exactly these two changes, right? So that we're defining these two code points so that now this update is aligned with the registry update. We think we need this, right? So if IESG tells us we don't even need this because it's good enough to have it in the registry, we'll see. But right now we're just duplicating everything we have in the registry into the update section of this draft. And then the new text, new semantics for MPLS labels before upstream and downstream, like sRGB, DCB, should reuse one of these two pre-existing values unless they cannot coexist with the pre-existing label semantics, in which case a new entry needs to be allocated, right? So if in the forwarding plane we really have a case where, you know, it's not good enough to know that the next thing comes from the global table or the next thing comes from some context table, but you need more information to continue doing the MPLS lookup correctly. I don't know if we even have a theoretical example for that. We could add that, but at that point in time, you would need to go the troublesome place of adding a third entry. And then the updates to sRGB and DCB 8402. Yes. Hopefully that microphone will work good enough for Greg. We had some microphone trouble, but you just go ahead and.
Is it working?
We think it works, but Greg is always.
I can't hear my own wonderful voice too, so I think it's working. Yeah, so I mean, I agree with all this stuff. The only comments that I had is from our point of view, usually a router would support either one or two, right? Like I haven't seen any implementation that does both so far. So far, if like Juniper sends two and we grab two and we process it as one, everything is working. Or then it becomes, to make Juniper happy, we send two out. We are enough, right? But we are actually acting as downstream anyway. So that's my only comment, that there will be cases that a single vendor is doing upstream, right? Because we are using that draft, I forgot the name, that Jeffrey has authored, but the other vendor is using downstream, and somehow these two have to work hand in hand, right? That's my only comment.
I mean, are these sRGB or DCB labels or other type of labels then?
So, yeah, that's very funny because the implementation has become a little bit twisted. So Nokia uses downstream assigned service label, whatever you want to call it, VERF label, whatever it is, right? So we do, originally we support downstream assigned. Upstream, sir? Hold on a second, I always confuse this. So your draft is downstream, right? Okay, so my apologies. Nokia supports upstream assigned originally, right? To be compatible with Jeffrey's draft, what we do is that we go into the VERF and we say all the VERF with the certain route target, they need to use this DCB label, which we configure manually on the VERF. I just want to stop right there. Are you following me?
No. That's, I was going to ask that.
Okay, sure. Yeah, go
So one observation between first, small technical discussion, but it's being transcribed, so please name affiliation, especially if you start to talk vendor compatibility, okay?
That was Human from Nokia.
Yeah, and purely technical,
You're booming the room.
yeah, sorry. And purely technical, it was intended. Purely technical, if your implementation needs to change the interpretation of the label, you can always CLI and not it as a
It's
feature.
not, I'm being purely technical so the gentleman understands what the problem is. Eventually, you need to be technical, right? So all I'm trying to say is that eventually there needs to be a case that upstream and downstream, they work nicely together, because a router would support either only upstream or either only downstream. And there is a way to make this work nicely together, as we are going to demonstrate in February.
So I thought
Nokia
that,
does upstream, and we will honor downstream when that BIER header comes to our data path. We will honor downstream, and we will send out downstream as a protocol, call it a hack. But from our implementation and a stack point of view, everything is working as it should.
Okay, let Jeffrey chime in, thanks.
Jeffrey from HP. I just want to clarify that a full BIER router that supports the over this day needs to should support both downstream, upstream. A vendor may choose to implement one way in the first phase and may add another way in the second phase, or they choose, okay, I'm going to implement one way and not the other way. That's the vendor's choice. But that only means that if you only support one way and the other vendor only supports the other way, then they just cannot interrupt. I don't think we have a goal to make sure that one vendor you send out protocol one, and then another vendor can only handle protocol two that's going to interoperate. I don't think that's the goal. And this work we're discussing now basically says that if your label is from the global LFIP, then you need to use one. Otherwise, you use two. And that's the technical standard. And then when it comes to interop, you just have to do the right thing. If the label is from the global LFIP, you set it to one. Otherwise, you set it to two.
But Jeffrey, what's the ask? That in the errata, we have to mandate that for a full BIER compliance, you must implement both on the router? Because now think, I mean, we have to standardize to tell people if you implement this, it interrupts, which it didn't. With some hacks, it did fine, okay? But now what do we write in the technical spec if we go through errata?
I completely disagree with that, because Huawei, Nokia, and IETF, they all support upstream. So if you want to go down this way, you're going to have issues with BIER. Our job here is to make sure that we have end-to-end multi-vendor interop, not to say this is the only way, and if it doesn't work, it doesn't work, too bad. So Nokia is trying to make this work, right? And we are bending to HP now. Sorry, I was kept saying Juniper. To HP's way to make sure that BIER is successful. Again, I'm being very specific here. Nokia is bending to make sure BIER is successful with what HP is dictating. So again,
Human, that's just one interpretation. The other interpretation is you read the spec incorrectly, but this is irrelevant. Those are interpretations.
We did not read the spec incorrectly. No, hold on. No, let me correct you there. We didn't read. Our implementation is upstream, and that's what we support. So we can go into the world and say that, hey, we do upstream, and we are not gonna interrupt with HP, and then BIER will be broken.
Can I just...
All valid concerns. Our job here is to write the spec when people implement, the stuff interrupts.
Which
and reads clear, okay?
So, but what I'm trying to tell you is for BIER to be better, this working group needs to understand this is very complex. One vendor is going to do it one way, the other vendor is going to do it another way. So there's got to be a way for 1 and 2 to play nicely with each other.
Okay, or with right, you must implement two. I mean, I'm not advocating either
I-
way.
so
I'm just
Tony,
saying our job is to write something.
Right, so
When you implement it,
I think
interrupts.
if you say, if we will do 2, no, some vendors might never do it.
Mhm,
So
yeah.
you're going to have an issue here as a BIER working group.
Okay, can I?
Yeah,
Can I? So, I hope I understand enough of that, and obviously, as soon as we get kicked out, we can continue after the working group. So, to the best of my knowledge, what we're trying to do here doesn't really impact whether you're choosing upstream label, DCB label, or sRGB label. It just, helps to specify what sRGB and DCB label should use. Right, so basically, because they're a different type of label logically than a normal upstream label. So where in which RFC are we even saying what type of label should be sent and be supported for MPLS payload over BIER?
So that's my point. My point being is that if a router supports both protocol, then they need to be able to support both protocol. No problem.
Wait, what do you mean with protocol?
Well, 1 and 2, right?
No, wait a second. From the protocol label, from the protocol specification, I think we have upstream label, downstream label, sRGB label, and DCB label. Those are the labels. And I want to know an RFC that says, for interoperable MPLS over multicast in whatever MVPN or whatever use case it is, you should use which type of these logical labels.
Well,
this document just helps to decide then, I'm using upstream, I'm using downstream. That means I need to encode that as 1 or as 2. This doesn't. This draft does not help to say whether you should support and use upstream, downstream, sRGB or DCB. Where is that information?
Well, that's my exactly point. Well, my point is that until now, when we were getting a BIER protocol 2 on Nokia, we were dumping it. We were saying that we do not support downstream, get rid of the packet. Is that clear?
No, maybe to re-emphasize in a way that sounds better for you, I'm supporting you in terms of saying this draft is irrelevant for the problem you're trying to solve, which is that is an upstream label something that implementations should support, for specific type of uses of MPLS over BIER. Right. So if we haven't specified that someplace, maybe that's something that can be added as a different section, also accordingly update wherever the RFC that is, but we're not at that level. We're not at that level. We're clarifying currently only, currently we have 4 logical uses of MPLS. Each of them is using one specific code point here, 1 or 2.
No,
right?
Again, I'm agreeing with you. So this whole, draft came up because of the interrupt issue. Do you agree on that?
Yeah, and
so there was some confusion between
from what I'm
upstream
hearing
and
from you,
downstream.
from
and
what
we
I'm
are trying
hearing,
to clarify.
Yeah,
which is fine.
Yeah.
But
From what I'm hearing from you, we're not complete solving the problem, and we may need to look at that. But I think the point is that from what I heard from you also, and maybe that's what we better take offline. It's not clear whether the solution that you were proposing is something that we can cleanly write into the semantic of the 4 labels. So that's what we need to check out.
And I agree with that, but my entire point that I'm trying to bring up is that at least there is an implementation that, one router, one vendor is supporting upstream, the other vendor is supporting downstream, or the new acronyms that you have set here, 1 and 2. One vendor does 2, one vendor does 1. And there is a knob that on vendor number 1, you can enable it that accepts downstream and pumps out downstream while the implementation is actually in the stack as upstream.
Is the type of label even signaled in BGP? Or
all right. So now, Mana, you are in the queue. Do you want to say something? Because we need no widen the discussion. Jeffrey, Mana.
Yeah. Let me clarify one more thing very quickly. So purely in the forwarding plane, if a router gets a packet with a proto field 1, and that router only supports 2, then the packet will be dropped, and vice versa. So that's the situation, and that's an interoperability issue at the caused by the implementation choice, not caused by the protocol. Here we are solving the protocol. The protocol will the draft will clarify which value we should use when we send out the packets, and which vendor choose to implement which way first or ever or forever. That's the implementation choice, and that will be cause interoperability issues in the field, and that's not a protocol issue. That's a vendor implementation issue.
No, it's a failure of the standards.
I'm
Right,
after
we
Mehmet.
didn't write a standard tight enough
no, wait a
to
second.
allow
You're
for,
first, Mehmet.
for an interoperation.
Again, completely disagree, because if we go down this path, no vendor is going to talk to each other. To me, this is way too unnecessary. Having protocol 1, having protocol 2, it should be just MPLS, and the vendor will make it work. If they support downstream or upstream, they will make it work. If you have a single protocol, as it has been proven in the implementation, whether downstream or upstream, it doesn't matter, it'll work. Because when I get the label, to me, I'm upstream and I'm going to say, well, this label is for this route target. I'll put it into my label stack with the RT,
No,
and
that's
then
not
off
true.
I go.
No, I don't think that's true, because with the upstream labels or any other type of context label, you need to know that you need to look it up not from the global LFIP, but you need to look it up from
So
the context.
that's implementation. And
No, that's logic.
hold on.
That's
Hold on.
logic, because you can receive packets with the same context label, with the same to label, upstream label, with totally different semantics.
Yeah.
But by having a context in it, you know that you need to do the lookup
the context
with
can-
sufficiently more context, like whatever other field from BIER or incoming interface, whatever it is. That, of course, remains the next
Again,
layer of complexity.
You're not hearing me. The context can be in the incoming label table. How you implement your incoming label table, it's up to you. I can say incoming label X, it's only for verb Y. That's the implementation. It has the context, whether the context is sitting in the incoming label or whether the context is sitting in the service, it doesn't make it, its implementation has nothing to do with
No, that's
anything.
that's not how we standardized it, right? We have context labels, and the upstream label is an instance
Well,
of the context label.
sometimes you have to look at it based on the inputs that is coming in into this working group. And I'm telling you, this thing will work between 1 and 2, as we are going to prove it in February. So we do upstream. Everything is
No, that's fine. I
ILM.
mean, the more hacky the solution is that we're doing in implementations, the more trouble we'll have to explain it correctly in RFCs,
Okay, so
and that's
what is
fine as
your-
well.
What is your
We
what is your other option? Your other option
No,
is,
I first need to understand better if, for example, the type of label is even signaled before you're setting
it's a
this up.
configuration. It's really configuration. So when you go, you say, I want to do DCB, right? When you go into the MVPN and you say, I want to do DCB, as such, then you are binded to downstream. That's the draft. That's the RFC. So I'm okay with that.
Wait, which draft are we talking about now?
Well,
Signaling.
I don't know, the RFC that Jeffrey has produced in BEST.
Okay, so I'll need to catch up on that,
all
and
right.
then
All
I
I'm
can
trying to
help
say
to.
is that
That's fine.
we are okay if this working group is saying that, look, Nokia, you're doing upstream, and if you get a label that is downstream, Nokia, you should drop it. We will drop it, but there is not going to be intro. Huawei will not interrupt with them either. So what all I'm trying to say is great draft. It is not going to solve the issue that we are seeing on ENTC.
All right, but the real discussion is now, how do we write the standard so we get interoperability, so when people implemented stuff, we don't get in the situation again, all right? And there are multiple solutions, and I'm not here to push in any direction. I just here to focus the discussion. So we can write, there is a very strict interpretation of what 1 and 2 means in terms of semantics and upstream, downstream, and everybody must implement 2. We can write, this is the semantics, and implementation is absolutely free to configure to loosen the semantics and interpret it differently, just like you did. Okay, these are all possibilities which we can standardize, and we can play with the must and the shoulds. All right, but so far we had nothing, and that's why we found that the standard failed. We failed. Okay.
Which I 100% agree with you, but
Okay.
that needs to be the open conversation that all vendors are
Correct.
open to do this, right?
Yeah.
Again, I think this draft is great. I think we need to tweak it a
we
little
get the
bit,
point.
as you said.
Or
to make
extend
sure-
to
or extend-
Yes.
first
That's my
under,
point.
explain
Yes.
the semantics.
Thank
We can even document why the semantics was not precise
And I'm
enough
not
to
trying to
guarantee
push one way or
interoperability.
the other. All I'm saying is that as it is, it doesn't solve.
No,
the
it does
problem.
not. But that's why I try to focus the discussion. So how do we solve the ultimate problem that we failed as a standard? Clarifying the semantics fixing is fine. But if that forces us into a corner of a solution, which seems to me that for full BIER interoperability, we would have to force all the vendors to implement 1 and 2, that it is obviously not an acceptable solution to be delivered. So if the acceptable solution is, this is the semantics, you are free to loosen the semantics to guarantee interoperability if you implement just one of the options, then it's a fine thing for me.
Well, again, let's wait until ENTC because we are doing something on our side. We'll see whether that's going to solve the interrupt
Yeah.
issue with
Well, I mean,
HV.
Which may be the
let's
reality.
continue the talk after the meeting. Right? I mean, we're trying to
which
figure out.
is the thing that we may have to standardize. So take it to the list, and it's just a fine thing, right? We don't have. We're not here to win the purity prizes.
No,
right? We
I
are
agree
here
with
to
you.
deliver
I mean,
industry
that's
solution.
why I start putting the comment. I mean, I'm
Okay.
on this draft and everything, and I'm all good with it. But all I'm trying to say is, you know what I mean. So I'm not going to.
Yeah, we need either to
We
widen
got very
the
early
draft
on. This
or
does not yet solve the whole problem, but hopefully it does already help for more people to understand the problem and also have a more logical way for what happens in the forwarding plane at the lookup time, right? What we do about the semantics of the labels, what we need and must support. Hopefully at that level we find something that allows interoperability with a minimum amount of hacks.
No, they don't have to be hacks. Okay, Mara?
Zero is also a good minimum.
Mankamna from Cisco. So just quick question on the last paragraph of previous slide that, yeah. So the scope of this particular draft is only to BIER, nothing else, right? Not MVPN or anywhere else, because 8402 and 9573, they are non-BIER RFCs. Just wanted to clarify.
No, you just threw another big X in the thing, which is that these drafts are not necessarily written specifically for BIER, but no, I think that's fine. But I think they can have references to how they're being mapped into BIER, right? And if these drafts, if it is, what do we do? Yeah, right. So if it's inappropriate to say something about the mapping into the BIER next hop in these two RFCs because they don't want to have BIER specific things standing in there, then we would still make them updates, but we would not declare this as text for those RFCs, but amendments from this RFC to that standard when being used over BIER. So that's just textual change.
Okay.
Mana, sideways question. How many of those things are standards? How many of those are experimental?
Which one? These two?
Mm-hmm.
I have not seen. I think both are standard.
Right, then, our hands are tied. Experimental, we have some wiggling room, right? Just saying, when we write the text. Good. So what's the practical outcome? Of course, take the stuff to the list and then either work together to extend this draft to basically standardize, a behavior that will guarantee interoperability, or just run off and write another draft and let this one be just semantics clarifying draft, and the draft that you bring will be like, this is how this semantic has to work, and that's the wiggle room that we need to interrupt in case of a vendor implements just one. Okay. Once more upon the bridge.
So I think even though we had the heated debate earlier, I believe that the Humans did say that he's fine with this draft. And so I think at least we should make quick progress on this drafts. And then And the ultimate interop issue that will be solved, that needs to be solved at implementation level. But standard-wise, I think we should be able, we would like to make quick progress on this.
That's one opinion, okay? There's like 3 different vendors, 4 different vendors, right? And it would be ideal if amongst the whole involved vendor parties is like an agreement how to progress, you know? Extend that, get this first, write a new draft. Thanks.
Without looking, are all those vendors represented as authors or at least contributors to this draft? Is that Torless slow rolling to the mic?
Greg, do you want to start a vote for it?
No. The question is, are all vendors on this draft as authors? Because what we need is a draft with all the vendors as authors. Okay, and like I say, you decide. You extend this draft until it is an interoperability spec, not only semantic clarification spec, or you start another draft. Good.
So we had a slide for adoption, but the last slide I didn't show said we wanted to clear up all the quigs so that.
You won't call adoption?
No.
Ultimately, it has to go to the list. I mean, we can vote here,
No,
right?
I wouldn't want, because I want really all the important issues to be solved in before.
Well, but adoption doesn't mean that you cannot solve the issues anymore. It just means that everybody feels that is something that needs to be worked on as a working group item. And that's the only thing it means.
And I had this nasty remark that we could help bring down the time in working group, the stats for the IETF BIER.
That was more I'm here to get work done, okay, and not massage statistics.
Yeah, I agree.
I'll leave it up to Homan what he feels. So,
Homan, you want to call for adoption? Okay, answer is yes. So we should call a vote. We will have to go to the list anyway, so we'll put it on the list, but let's vote quickly. I think it's roughly formality, but let's follow that. Sandy, can you run a vote? Sandy's doing it.
Please vote.
Yeah, so no surprises here. Let's finish the stuff. Will be taken to the list, and it looks like that this draft will be the scope along human lines to actually to not only specify the semantics, but actually define enough behavior so we know that, you know, a vendor can implement just one variant, and then you roll a good language how to make sure that in such a case you have interoperability.
Okay, terminate.
I think this is a timer on it, no? Normally.
Timer. Do you want to start our timer? It's for presentation.
No, you
yeah.
can finish the.
Okay.
It's pure formality.
Thanks.
Good. Thanks. Now that was already pretty lively.
So let's move to the next presentation. So Greg, do you want to share slides or just show by me?
Sure.
Okay.
Says all media slots taken.
Yes.
How do we quit this? Huh. Who's got the slide clicker to end this thing?
But it seems like all the slots already taken. Sorry.
Sandy, just stop the share here. I think you are doing the share.
I'm doing the share.
Yeah, I think you got this one.
Really? It's controlled by Greg, right?
Yeah, that's the stop share. No, she's not sharing.
How can I stop the sharing? Yeah, you see, everything I can control.
Here we go. All right.
Yeah. Okay, good morning. This is the third time I present this draft. So today we'd like to introduce the LM MOE multicast use case again. Yeah, I'm Sandy Zhang from ZTE. So let's introduce the LM MOE at first, because that's the LM is a large language model which is deployed very much today. And the MOE is a new architecture for it. The MOE is the abbreviation of the mixture of experts. And if we use MOE to help the LM deployment, multiple experts will be activated during the computation. And in each expert, only part of the parameters will be used. So we know that because the language model is become larger and larger. So if we just use one GPU or one or two GPU to do the computation, the energy and the power consumed is very large, and it's difficult to achieve it just inside the node. So the MOE is a new architecture, and it's a trending architecture in the LLMs. And so we know that MOE can bring a more cost-effective training and inference method, which means that it can enable the deployment of larger models at almost the same cost. We can use much more GPU to do the computation, not just depends only on one or two GPU. That's dense mode. So for MOE, it's a sparse mode. Yeah. So in recent years, more and more LLMs adopt MOE architecture, such as DeepSeek V3, Llama 4, Mixtrail, and Queen 3 eccentric. Yeah. And the gating function is the most important function in LLM implementation. When using the gating function, the experts are selected. So the token will be sent to the selected experts for computation. This, for us, we know that it's a typical multicast use case. So let's see the MOE deployments here. And this is a table for the mainstream LLMs, such as Google and the XAI and the Mixtrail or DeepSeek and so on. We know that the first MOE business LLM is Mixtrail, which is published in last year. And in this year, we know that several LLMs published their MOE versions. So in Mixtrail, we know that it has 8 experts and 2 experts are activated at a time. One is a shared expert and the other one is routed expert. And in Llama 4, for different version, there are different number of experts. In Scout version, it has 16 experts and 2 experts are selected at a time. And in Maverick, it has 128 experts and still 2 experts are selected at a time. And when we use the DeepSeek V3, we know that it has, just for now, the largest numbers of experts, 256 experts, and 9 experts are activated at a time. One is shared expert, and the other 8 are routed experts. Yeah. So in that, it's a trending architecture of LLMs. And this picture is from the DeepSeek V3 paper. We know that this is gating function in the expert select process. The experts was selected from all of the experts. And we know that in LLM, the expert balance is the most important things here. So we can't limit fixed set of experts to be selected for the token. So maybe every time for each token, we'll use different type of experts. So, and we know that that's a large number of experts here. We can't deploy all the experts just inside one node, and it must across several nodes. So the communication from the experts will be across at least leaf switch, even spine switch. So, and we know that from the MOE architecture, the EP, that's expert parallelism, is used to replace some of the tensor parallelism TP. So it can achieve the goal of sharing the abandon. So the motivation of this draft and our goal in yesterday side meeting, we'd like to use network multicast technology to assist the LLM as a multicast implementation. So we'd like to reduce the pressure of the source GPU because more selected experts are, and more queue will be managed in the source GPU. And it's also the latency problem or bandwidth problem and memory problem, yes. And we'd like to reduce the probability of congestion caused by bandwidth between nodes. We know that the bandwidth inside the node is larger than the bandwidth between the nodes. So because the communication will make, the EP communication will make the data be transferred across the leaf switch or even span switch, the limited bandwidth will do limit the data transfer. So we'd like to reduce the possibility of congestion here, yeah. And also we'd like to find the possibility, just the possibility to use multicast for use cases just inside the nodes or outside the nodes. That means scale up or scale out network. But at first, let's solve the problem in scale out network, yeah. So, but we know it's not easy thing, and we have several gaps here. You know that currently the sending methods within the card is just memory reading, and we know that between cards, a link will be used, and between nodes, RDMA is usually used. So it's all different type of the data transfer method. Yeah. So we may need a coordination between large model coding. So the large models need to be modified, and maybe also the communication library and the network card and the network layer. Yeah. So we'd like to find the suitable location for the multicast packet encapsulation. And also we may need the management of experts, especially in MOE scenario. Yeah. So there's some, Torres, do you have
Do
questions?
you mind a question?
Yeah.
So the one data point that I would be interested in understanding the importance of multicast would be these things that are being sent to these groups of experts.
Yeah.
Can you describe how much traffic relative to the bandwidth of the network that is? I mean, if I'm thinking about just what I type into ChatGPT as the queries, I think that even if the whole network, even the whole data center is only running these AI chatbots, then that type of stuff would be a very insignificant amount of traffic. And that was, I think, the big part of the discussion on yesterday. Then we set up stupid PIM flooding trees and sent them to all the experts, and they discard, you know, the ones where they are not addressed. But if it's significant amount of traffic, then we have a good story for BIER, right? So that seems very relevant for what we're. I'll take you. Yeah. Okay.
Okay. Let me explain it in detail, because we know that
Yeah, come, Jeff. Yeah, contribute.
Jeff,
I mean, this yesterday we have kind of same people, and I want to see the same discussion yesterday in the side meeting. There's no purpose, and you were absent. And
I
you'll
will
have to
invite-
explain. Okay, so
Just consider NVIDIA. So router you see here is not an AP router, even so that's how we understand. It's an MOE router, and it's a logical function that decides who to send traffic to. So it decides who the experts to work on particular part of the problem. The decision is taken with a number of microseconds. So practically, this is why the solution doesn't belong in classical multicast. You won't have enough time to build the tree, right, dynamically. I know what you're going to say, so I'll come to
no, let Jeff continue and
finish.
then we can correct. it.
Right, so practically, the only way to implement this, if we are going to do it over multicast, is in data plane. Contraplay signaling is out of question. It's too dynamic, and the amount of time between the decision to use particular group of experts and actually start sending traffic is number of microseconds, right? So the signaling is out of question here. The potential approach to this, which I call lazy approach, is actually broadcast, he said. Broadcast has a couple of nasty properties. One of them is that you indiscriminately send traffic to all NICs. Most NICs don't implement QoS on ingress, and receiving traffic that's actually they're not interested in will result in some really nasty effects. I'm not going to go into details, but just kind of lazy broadcast is not a good idea here. So it needs to be more intelligent than that. So maybe a combination of a GMP from the host, something in practically this work belongs here because again, there's no signaling. There's no time to do the signaling. And the trade-off is on one side, what we see now is reasonably small expert domains. We know that they're going to grow. The data centers with 500,000 GPUs are coming next year. We all know Stargate is being built. So the expert groups are going to grow above 1,000 experts. It's kind of well known too. So practically you need to deal with header size and make sure that your payload is at least larger than your headers. Otherwise, what's the point? Right? So all of this kind of create multidimensional array of issues that needs to be looked into, but it's a right place to think about it.
There's one important data point, Jeff, you may give us. What is the volume of the data that would have to be sent to an expert? And what is the trend? That's more interesting, right? It's small today, but it will grow. It's a different answer than it's reasonable.
It's reasonably small. It's at max couple of gigs.
Well, yeah, you consider it small, okay. But will the experts rely on more and more context? And with that, it means that you have to shove to every expert more and more stuff because, to generate the answer, you will need more and more context to understand what is going on, or will it stay relatively stable?
I think it's a great question, and the partial answer to that, more expert will result in more all-to-all or synchronization across expert group, which is unicast. It cannot be multicast. So from this perspective, it's not necessarily resulting in more traffic that is kind of MOE distribution.
Okay.
So I'd
Yeah,
like
and
to-
just to quickly, the broadcast idea, obviously that needs to, the details understood, right? If it's really classical broadcast, fine. But if we just use devil's advocate, right? So devil's advocate said, we're building to the total set. Devil's advocate is, by the way, he's called Dino. And yesterday, right? So he was bringing up that thing. So I'm just channeling him. No, he didn't mention this, but just PIM, right? So you build up a static multicast tree that goes to all the receivers, right? In the worst case, I have an application layer, a bit string mask that says, for this packet, for this request, this is the subset of the receivers that processes it. And then if we're lucky, we define that as just, let us do some tricky thing that it can be BIER, but right now it would only be processed, let's say, by the smart NICs in the servers that do it. We don't need to do upgrade things in the network. Bad for us in BIER, but it gets multicast at least established in the place, and maybe we have a way to shift over to full BIER.
Yeah, you basically run, user space BIER, so to speak, overlay BIER.
Something like that.
Something like this, yeah.
So I think if you need to encode each receiver, inevitably efficiency of protocol will go into really bad place. I think interesting idea here is to abstract and say, I only need to get to a particular switch. And then some local signaling might take care about who receives, who doesn't receive. And so again, there's space of trying to find more optimal solution rather than just trying to bug each NIC, which is really bad idea.
Let's take the inference, for example, because we know that the previous question from Torres is how many communication and how many data will it be sent just by the MOE architecture. We know that it depends on the output tokens. So because when we use the RM more and more, you may need a very long output token, right? Because we know that in inference stage, every token will be sent with the previous token. So those will send all the token, always send all the token to the MOE experts to computation. So if the context is very long, the output tokens is very long, just the data you send is become larger and larger until the end. So you know that it's difficult to say how many data will be sent because it only depends on your output token. Yeah, and we know that in the long context scenarios, the output token will be more and more. So it will be large, and it will be sent to all the experts for computation. And so that's why we want to introduce multicast for help them to do the things. Yeah.
So in general, today we do it point to point, right? It's kind of ingress
Yes,
replication in a
unicast
way.
is used now. Yes, we know that.
So there's no multicast in the AI networks in general, right? So yeah, the point is if amount of traffic remains slow, introducing this complexity probably not worth it, and it's a significant investment. You need to build this technology, you need to operate it. It's something that's not done today, and when you talk to data center people about multicast in general, they kind of drop that, right? So it really depends, and probably next year will be much more representative of this one, whether it's worth investing into this.
But you said something intriguing that it would, it may be just enough to actually support something like that on the switches. And given the success of Sharp, it seems doable. So is your message like, you know, the barrier to entry to talk about this kind of stuff, economically speaking, would be to talk about switches and not touch NICs, because that's where the adoption curve
That might be
becomes
much
exponential. Okay.
much more pragmatical approach,
Okay.
at least to begin with.
Yeah, which makes also the addressing space, even in very, very large substrates, you know, quite small. Okay.
So we just discussed the possibility. Yeah, right. So let me continue. This is some existing network multicast technologies. For PIM, we know that it's a traditional multicast routing protocol and it's stateful. That means that the state of each flow will be maintained in the router or switch. And it requires periodic signaling to build a distribution tree to forward the flows. Some of them maybe say we can suppress periodic signaling, but it may need some change for the base protocol. And we may face slow convergence if the tree topology changes. And we know that the PIM encapsulation, the multicast encapsulation for PIM is based on IP. So we know that for BIER, it's a new multicast technology and it's stateless. It means that we no need to maintain the per group or per stream state on the switch or on the router. So we needn't build the distribution tree, and the forwarding is done just based on topology. And we can achieve faster convergence to network changes because we needn't rebuild the tree. And the BIER header encapsulation is flexible. We have Ethernet, MPLS, and IPv6, and we may do some change for it to make it more efficient. Yeah.
We forgot the most important thing. It must be reliable. And reliable
reliable.
multicast
Yes.
has been pain in every possible part of the body for next 30 years.
Yes,
So
we know.
that's the solutions that must come here, otherwise we'll keep doing point to point.
Yeah.
You need to be able to know if packet has arrived and you need an ACK.
Yes, we think the reliable is the most important things in AI. We know that because latency and we must maintain the latency is in low level and it's no packet loss here. So the multicast technology need to be used with the existed reliable transaction function, such as the link layer function. We know that UEC just published the specification 1.0 or version 1, right? And the LR link layer retransmission and the CBFC, the forwarding based on credit can be used always with technology to guarantee the receiving of the data. So we know that it can help to keep the reliable, it can help to improve the reliable in multicast. Yeah, Torres.
Yeah, I forget about it, right? So RMT stuff is not going to successfully deployed in something, environments that don't already have a lot of experience with that, right? So all the really business critical multicast that we've seen in large network finance or TV or any of these other things, they were all based on high priority, no loss incurred, right? So that there are enough networks that had terabits over weeks and didn't lose a single packet by just doing, the traffic calculation and being sure this is the highest priority stuff. We're never going to congest, so we're always going through and nothing gets dropped. That I think is the only way forward.
Thanks for the upbeat assessment. Yeah. Well, I mean,
that's the
it's an
experience from-
unsolvable problem since 40 years, which means that it will be easy this time. Fortunately, it's definitely out the charter of this working group.
No, but I think it's a dependency, and I think we should not ignore that we do have a lot of experience with just doing out-of-band admission control, controlling the traffic, setting up the QS, doing all the things that multicast always makes it through, and we don't need RMT.
Okay. So interesting perspective, and we should ignore it because it's not in charge of this working group. But if this is the problem, this is the problem that would need to be tackled. I mean, observation is good, right? It would be probably easier to probably architecture the network, especially if you have something, like InfiniBand mechanisms you could drag into this kind of stuff rather than try to build a proper reliable multicast with hacking and necking, and we know where that stuff, it's a wonderful black hole for the last 40 years. Yeah. Okay.
So this is because I want to show that the BIER standards is mature. Yeah, so you can see that we have published many RFC for BIER technology, and we can use it for in data center. It's ready, right? And we can also have some encapsulation selection. Yes. So and maybe BIER will be an ideal choice for implementation. Multicast in RM, especially for MOE scenarios, because we think that the MOE scenario is the most explicit requirements.
Yes.
So that's the same open questions because we have faced many times this week, though, that maybe we think that one general multicast technology can be used to solve all the problem here, or we didn't use any multicast technology, just unicast, or we can use some specific technologies for the specific use cases, such as MOE. Yeah. Mm-hmm. And this is imagination or just the startup for implement BIER in MOE. That's for MOE scenarios, and we can consider each expert is a BIER, and it can be appear is a bit in the bit stream. And the token can be encapsulated in a BIER header and sent to selected experts by BIER forwarding on leaf switches or even spine switch. So we may need a coordination with each expert batch. We know that the token sent will be in the batch queue. So we know that we can working with the interface to work, to make it work. Yeah. So that's all.
From my side, what I heard were two actually very interesting inputs, just looking through the working group perspective. One was that adoption just on the switches may be something to look closer at. I don't know whether it presents any new problems and whether it's an obvious thing, and stay away from the NICs. And the other was Torles' observation, which is intriguing, whereas something like BIER with proper, credit-based reserve reservation would open new perspective, just like we have BRTE, right? Maybe something like that bears discussion if enough interesting parties come to the fore. I mean, whether you're doing BIER working group or not is a completely, discussion that is of no relevance here. But maybe that is actually much more of a promising path that going down the black hole of reliable multicast and unreliable medium. Okay, I think as finishing thoughts, I thought those two very interesting inputs here.
Yes, let me say it again. It's the requirements is really from the LLM operator, or the LLM, which is the DeepSeek. So they require the multicast to help them to solve the problem. But you may say they don't know network layer, so they maybe just their imagination. But we like to help them to do the work and to see if it will make advantages for them to improve their efficiency. Yeah, that's our goal. So it's from actual requirements here. And we'd like to find some solution for it. And we may just push a demo or something else, a quick implementation for it. And we'd like to receive all your comments and suggestions to help us to improve the solution. Yeah.
I think the question is where in the IETF to best discuss these things. So I'm not sure you folks, Yingjin and you, don't you have this data center AI kind of thingy? Is there a mailing list for that? And there's also Dirk, who has started for the IRTF, kind of the question, right? Kind of what are research questions for AI? They have Net for AI. So I sent a long rambling yesterday about this multicast thing that I would like to see more data. This was still the best one that I've seen here in the IETF in terms of the data of how much traffic or so. I don't even care about them trying to understand the multicast problems, but just, what are these traffic things? Where is traffic that is sent multiple times to multiple receivers? How big is it? How imminent, right? So when we collect this data, get more analysis, and I think that's what we need to collect from more the application folks. So where do they hang out in the IETF, right? So where can we get engaged? And then I think we can circle back to, to BIER and PIN and see what we can do in the network.
Peter presentation in ITC side meeting is very useful, and we can achieve the basic concepts from the inference stage. So we can get more from him. So I request the presentation in ITC, but it's no time for me. I just want to clarify it. Yeah.
So you're asking questions, right? The presentations ADC mostly meant to give some kind of answers. Right?
Yes, we know that it's full.
But I think what it's going to boil down to, I think, kind of EVP and data centers, very good example, right? We spent really a lot of time and effort building efficient replication, but practically 90-something% of deployments use ingress replication, right? So if this solves real problem and significant problem, probably there's going to be development and eventually we build something. If ingress replication or point-to-point is good enough, again, which is good enough for most VPN deployments in data centers, probably it's going to stay this way because the complexity and cost of implementations is high.
I would like to offer some really stupid data points from the past, not from data centers, but from wide area network providers where I went and wanted to tell, hey, for your TV multicast, you can improve your network so much by our new, was not flex LSA, but better routing. So currently you're sending all the traffic twice through the network, even though it's multicast because of routing, and we can reduce it to one. And they said, oh, wait a second. So you're saying multicast does create excess traffic when we're extending it. Oh, that's great. We can buy the upgrades faster, right? They didn't want to have the better routing to make multicast more efficient. They were happy that there was excess traffic, right? So it's not clear whether the people who have a say and the people who pay the money are on the same page as to, you know, what the most cost-effective solution in the network is.
And cost per bit of data center is completely different than this asset.
Yep, but those are all movable data points very often, right? And within a year or two, realities look completely different. However, you know, the long-term requirements instilling that is an important thing, and bit technology can be consumed in work and interrupt. All right, more?
Okay, thank you.
Yep. We have another 10 minutes, if anything's pressing. Greg?
I'm still awake.
Yeah, you are. You're like 7 now, man. Time for coffee.
It's 4 a.m.
Yeah, you definitely have to move. Wrong time zone.
I had 2 back-to-backs this morning. I started at midnight. I'm all right.
Yeah,
My cat's pretty pissed off, though.
It's about as much empathy as you can expect from me. Okay, with that, I think the beer session is closed for today. Thanks for participation. It was lively. I think the first draft is very important, and this is, you know, something. If you don't know what to talk about, you know, once you're having a beer in the bar.
Looking for business.
Yes.
Looking for new business.
Yeah. Later. Thanks.
Thanks, everyone. Good night.
Good night, good morning.
He is probably barely functioning. Yeah, sorry, I was caught up in something, but yes, there was blood in the bar. So.